This video is on exponent rules or exponent properties. The next rule we're going to talk about is called the quotient rule. The quotient rule is when it is division and the two bases are the same. So it's divide, you'll see a divide, and the two bases are the same. So as with the product rule, the bases have to be the same. If the bases are the same, we continue to write the base, but instead of adding the exponents, we actually subtract the exponents. Now there's a key piece here. You actually keep the variable, wherever the variable is, wherever the bigger exponent is. That's important to remember. So the general statement of this, we have x to the m power divided by x to the n power. So this is a division, and we do have the bases of x are the same. So what we do is we write the base again as x, and then we take our bigger exponent and subtract our smaller exponent. And generally it is the top minus the bottom, but that is why we put the variable wherever the bigger exponent is, because we don't want to deal with negative exponents unless we absolutely have to. So we would do the top minus the bottom in this case, because we don't actually know what the variables are. We don't know what the exponents are, if m is bigger or n is bigger. We're not really sure. So we would write the x as the base, and then we would take our m and subtract the n. So if we look at this first example, we have x to the fifth divided by x squared. We do have the same bases of x, and they're being divided. That means that we will write the base, but we do want to keep the variable wherever the bigger exponent is. So currently, the exponent of 5 is the bigger exponent. That means when we write the base, the x to the fifth is in the numerator, we're going to write the x in the numerator. So this will be equal to x in the numerator. And then we're going to take our big number minus our smaller number. And that's why we always put it in the location where it belongs, so that way we don't deal with any type of negative exponents. So since this is going to be in the numerator, we're going to take our 5 and then subtract the 2. Now the denominator, since there's nothing actually in the denominator, we do put the number 1, but you don't actually have to write that. The whole reason for this is to make sure that we know where the exponent or the variable goes. So in this case, we don't actually have to write this division of 1, because divided by 1 keeps everything the same. That's an identity. So since this is a variable and numbers, we can simplify this into an expression. This would be x raised to the 5 minus 2 is 3. So our answer, or to simplify this, was x to the third power. On this next problem, we have 3 to the fifth divided by 3 to the third. This is just like with the product rule. When you have bases that are the same, it doesn't matter if they are letters or numbers. These have the base of 3 and 3. That means that we can continue doing this quotient rule. The bases are the same, and there is division. That means we are going to write the base of 3. Nothing changes with the 3. And then we'll subtract the exponents. We want to keep the variable or the base wherever the bigger exponent is. So currently, the exponent of 5 is in the numerator, so that is where we will be putting our base. The base of 3 stays in the numerator, so we would have division here. Then we would do the bigger number minus a smaller number, the exponents. So we would have 5 minus 3. Nothing is in the denominator because we have already utilized this 3 cubed and put it up into the numerator with the 5. That means that the denominator is technically 1. And again, since there's only one base of 3, we don't actually have to have this division of 1. So we can simplify this. This becomes, since there are no variables, I'm going to simplify it, and then we simplify it again. The base of 3 raised to the power of 5 minus 3 is 2. These are only numbers, that means that we can do what 3 squared is. 3 squared means 3 times 3. We just write it twice. 3 times 3 is 9. Now we could write out what 3 to the 5th is, actually figure out that value, and then figure out what the value of 3 to the 3rd is. And then we actually divide the numbers. Well, those are very large numbers, and it's a little bit simpler and a little bit cleaner to simplify before you try to do any division, especially if you don't have the use of a calculator. Okay, this last one, we have multiple bases. We have x's and y's. You can only have one of each letter, so if you notice that there is an x on the numerator and an x in the denominator, we're only allowed to have one of them, just like we did on a here. So let's do this as 2 separate bases. Let's look at the x's. We have an x and an x. The exponent for the x's are bigger in the numerator. That means my x will be in the numerator. Then I take my big number minus my little number, so I have 2 minus. Well, what is the exponent on this x in the denominator? Since you don't see an exponent, that invisible math tells us that that really is in fact a 1. Then we're going to do the y's, because that is our next base. We have a y and a y division. That means they are the same base. I'm going to write the base, but where? Wherever the bigger exponent is. Right now, the y has an exponent of 5 and 3. The 5 is bigger. That 5 is in the numerator. I will continue to write the y in the numerator. Then I take my big number, my big exponent of 5, and I subtract my smaller exponent of 3. Since these will both have letters and numbers, that means my simplification will not be just a number, and when I subtract these values, I'll end up getting the final answer. The x, the base of x, will be raised to the power of 1. That means I can put a 1 there. But x to the first power is the same thing as x, so you don't actually have to write the 1. So we can write just x times, then the y. Y is raised to 5 minus 3, which is 2. So our simplification of this problem, x squared y to the 5th divided by xy cubed, simplifies to xy squared. And nothing was in the denominator because the only 2 bases we had, both of them went to the numerator because the exponent that was bigger was originally in the numerator.